All right, class, for our first video, we're going to be working through the rules for multiplying and dividing exponents. And we want to start off with multiplication, and I want you to pay very close attention to the two A's. These are what we call common bases. And this rule applies when we are multiplying common bases. I'll illustrate the opposite of this in just a moment, but we want to see that both of these are the letter A. In the examples that follow, you'll see an X and an X, a 2 and a 2. All right, if those are the same, then here is my rule. When I'm multiplying common bases, I add the exponents. So a to the m times a to the n is a to the m plus n. All right, and so now when we look at a couple of examples, we have x squared times x cubed. Well, the bases are the same, aren't they? They're both an x. And so I'm going to write down the base and then add the exponents. 2 plus 3. So this would be x to the fifth. Now what about some numbers? Notice that they have the same base. And now notice that I write down the 2. I'm following the exact same pattern I did in my first example. In other words, this is not 4. I do not multiply 2 times 2 and get 4. And I'll illustrate why in just a second. But since it's the same base, I write down the base and then I add the exponents. I add because I am multiplying. And this becomes 2 to the fifth power. And if we could take it a step further and say that that is 32. 2 times 2 times 2 times 2 times 2 is 32. Well, how else can I see this being equal to 32? I can see that 2 squared is 4. 2 cubed is 8. What's 4 times 8? Well, it's 32. Let's look at another example. What happens if I have an x times a y? Now, x does not equal y. Therefore, they are not common bases. So I don't say xy to the fourth or something like that. I would simply write it down like this. X squared, y squared. I can't add the exponents. I can't do anything. They're not common bases. So I'm stuck. This is actually in a simplified form. Now let's look at division. Got a couple of examples here for division. Now when we multiply common bases, we add the exponents. But when we divide common bases, now we have a divided by a, we're going to subtract the exponents. So a to the m divided by a to the n simplifies to a to the m minus n. Now don't let these rules frustrate you. Let's look at some examples. What if we have 3 cubed divided by 3 squared? Well, they have the same base, and so I'm going to write the base down. It's not 1. We don't divide 3 by 3, and I'll illustrate this in a second. We leave the base alone, and then we subtract the exponent of the denominator by the exponent of the numerator. So this would be 3 to the 3 minus 2, or simply 3. Let's look at this a couple of different ways. What if we come down below and we say, okay, 3 cubed is 27. 3 squared is 9. What's 27 divided by 9? Well, it's 3. And so we see it that way. We could also play around with it this way. 3 times 3 times 3 divided by 3 times 3. 3 times 3 times 3, right here across the top, that's 3 cubed, isn't it? And this is 3 squared. So we could say, all right, well, anything divided by itself is 1. So those 3's are gone. 3 divided by itself again is 1. There's a 1, there's a 1, there's a 1, a 1. Wait, look at this. If we multiply straight across the top, we have 3. 3 over 1. So any way we look at that, we end up with 3. All right, but it's so much easier. I hope you can see that this way works, but it's a little bit more labor intensive. Especially, what if this was 3 to the 25th divided by 3 to the 18th or something? You really want to apply the rule. This works, but again, what happens if I get 3 to the 15th? A large number, I'm not going to want to do that in my head. But applying the rule, when I divide common bases, I can subtract the exponents. That makes it a lot simpler. So one more example. What if we do x to the 5th divided by x cubed? That's x to the 5th minus 3, or x to the 5 minus 3, and that's going to be x squared. All right, so I hope this helps. Some simple review of the rules of multiplying and dividing exponents.